All right, so we are back at it. So now we are working on the chi-squared test, question 2. So first thing we need to do is import the data set from Excel. This one is called students, so wherever you have the students data set, you're going to want to upload that. I currently have it open, so it's not letting me load it. And here we go. A lot of information on this spreadsheet. So we're going to hit import. There it is. Fortunately, we don't need all of this. But we have read the Excel data file. Now we're going to create the cross tabulations tab. So we're just going to call this one tab 1. And it's going to be a table that's going to be a cross between the year and the review, right? So the year is their what's standing, and the review is whether or not they participated in the review, right? So they were either there or not, as signified by a 2 or a 1, right? And a chi-square test, in case you didn't pull it from class, the chi-square test is pretty much the same general thing as an ANOVA, except you have categorical variables. So it either is or it isn't, or it's different levels. It's not a continuous thing, right? So so we define it. I'll type it out to show you guys. So whatever you want to call your object, right? As long as you can keep it straight, but it's got to be a table, and we want to pull from the students Excel file that we just uploaded. We use the $sign to tell it what column we want, and we want the year column, and do that same thing again. Students, $sign, we want the review column, right? And define our object. So now we have a table called tab 1, and let's just take a look at it, see what it looks like. And here it is. I got our variable 1 and our variable 2 and the frequency with which each of those occurs, right? Variable 1 being class standing, variable 2 being whether or not they attended. So now we're going to run the chi-square test. So to do a chi-square test, you don't need any special packages. It's just chi-sq period test. And the two variables. Oh, hold on. Sorry. Let's go ahead and create our bar plot. Right. So this is just a bar plot of table 1. So this is just how we're visualizing our data. You can see the different color bars are the different class standings. And then 1 and 2, we don't know which one is the review session and which one is like missing the review session. But you can generally see that a lot more people fall into category 2 than in category 1, whatever that is. It's really hard to tell if there's systematic differences, right? That's what we're figuring out with our statistic. So we're doing chi-square.test and the same things that we typed in here. And then it's asking us if we want to do a correction, and we'll say no. We don't need a chi-square correction. Just run the data as it is. So it just tells us there's a chance that our information might be incorrect because we didn't do a correction, but that's fine. So taking a look here, we see the result of our chi-square test, our degrees of freedom, and our p-value is much greater than 0.05. which means that we are going to fail to reject the null hypothesis, which means that there's not any differences between the groups, right? And that is kind of what we see here. It seems like each of the different classes, there's just more of them in condition 2 than in condition 1. So say this is everyone who attended and this is everyone who didn't. Most of the groups just about double in size. Maybe seniors don't quite, but overall, it doesn't really seem to matter about class standing. If we wanted to get really technical about this, we technically could have grouped these, the upperclassmen versus the lowerclassmen. But if there's not differences at this level, looking at all 4 factors, there's probably not going to be differences when you combine factors either. I'll show you guys how to report that in just a minute, but you can see the chi-square test is much easier. Let's go ahead and do what we need to on here for question 4. So we've already uploaded the Excel file. So we're going to do, we're going to create another one, and let's not do the same thing. Let's call this one tab 2, right? And then we're going to view. So I'm correcting all of the syntax here. So we're going to create a new table. We're going to call this one table 2. And this time we're going to do gender and extra credit. We want to know if there's gender differences amongst those who did or did not do the extra credit. So we define that, and then let's take a look. Right, here's the data. Right. And there's fewer levels of the variables because they either did or didn't do the credit, and there's only 2 genders to consider. There's not 4 different class standings. So let's take a look at that bar plot. You will need to copy and paste this over into your chart. So once it generates a new image, the old one is gone. You would have to rerun the thing in order to do it. But we run the bar plot and we can see the bar plot here. Looks like 50-50 in this condition. It's not 50-50 here, but that doesn't mean we have a statistically significant difference. It looks like there might be one, but let's actually run the numbers. And it's the same format as we used before. We're not doing a correction. We run it, and here we go. So you can see the p-value is greater than 0.05. So once again, there's not a statistically significant difference. And so now we are ready to report.